Welcome to all. I am Nagarajan, Assistant Professor of Physics, Government Private College, Kolar. This is about Bangalore North University, third semester BSc Physics, paper 301, Electricity and Magnetism. These are the learning objective of this session. So we can describe the effects of magnetic force between two conductors and the definition of ampere. So after completion of this session, we can able to follow the concept of magnetic force between two parallel conductors carrying a current and also the direction of magnetic field and the definition of ampere. So to find the force between two parallel conductors, so we have to consider two infinitely long parallel conductors X and Y separated by distance r in free space and carrying current I1 and I2 respectively. So we know that a current carrying conductor experiences a magnetic field or produces a magnetic field. Since these two conductors X and Y produces a magnetic field V2 and V1 respectively. So consider a point P in the conductor Y. So this is a point P on the conductor Y. The magnitude of the magnetic field at P on the conductor Y due to the current element I1 produced by the conductor X. This I1 produced by the conductor X is V1 is equal to mu naught into I1 divided by 2 pi r. So this already we know this relation to derive this. So then the force experienced by the conductor Y due to the length L under the influence of B1 is given by F2 is equal to B1 I2 L. So the force experienced by the conductor we know already we studied. The force experienced by the conductor F is equal to BIL. So then you will get the force experienced by the conductor Y of length L under the influence of the magnetic field V1 is given by F2 is equal to V1 I2 L. So if you substitute that V1, then F2 becomes mu naught I1 I2 divided by 2 pi r into L. Therefore, the force per unit length of the conductor F2L is equal to F2 divided by L. Then if you substitute, you will get F2L is equal to mu naught I1 I2 divided by 2 pi r. So according to the right hand rule, the force F2 is along the plane of the paper and directed towards the conductor X. See, this is F2 is directed towards X. And the conductor X also experiences force and directed towards Y. Similarly, the force on the conductor per unit length F1L is equal to mu naught I1 I2 divided by 2 pi r. So therefore the force per unit length between the force per unit length between the parallel conductor F is equal to mu naught I1 I2 divided by 2 pi r. That means the force on two conductors will be attractive if they carry currents in the same direction. So now in the diagram you can see the currents I1 and I2 are in the same direction, therefore the attraction takes place. If they are in the different direction, a repulsive takes place. So then we can define the unit of current, ampere. So in this equation, F is equal to mu naught I1 I2 divided by 2 pi r. If I1 and I2 each is equal to 1 ampere, then these two parallel conductors separated by 1 meter distance, then F is equal to 2 into 10 to the power of minus 7 Newton per meter. Thus, ampere can be defined as that current which when flowing through two infinitely long straight parallel conductors of negligible cross section placed in vacuum at a distance of 1 meter from each other produces a force of 2 into 10 to the power of minus 7 Newton per meter length between these conductors. So finally, here you can clearly follow the definition of current and the force between two parallel conductors, and these are the references I have chosen. Thank you.